Hi guys, good afternoon. This lab exercise 6 would be all about naive-based and logistic regression. And here we are going to know dataset preparation. There might be some very technical words that will be mentioned, no? So naive-based classifier, logistic regression classifier, the text classification, both using naive-based and logistic regression, and you're going to compare and reflect the two. Do not worry about these technical terms since you can actually use AI tools like ChatGPT or Gemini or things like that for you to know more about this and some of the terms that you could also search before you start doing on this laboratory exercise. So let's start. So for the task one of this laboratory exercise, we are going to prepare the iris dataset and also the breast cancer. So you can see here this one, the SK that learn that datasets. You've been using this since laboratory exercises 1 to 5, I think. So this actually provides built-in benchmark datasets. And then this one, the train test split, of course, this is another library that splits data into training and testing sets. And of course, the standard scaler, we scale, just like what we did in lab 2. So it standardizes features to have mean from 0 and standard deviation of 1. And these are very important because these are core processing tools in supervised machine learning. And so when we load the iris dataset, we use this iris equals load iris. And then this one, the x sub I, and y sub I is the x sub I rather would be the feature matrix. So in that case, if you try to open the data, the xi includes the sepal or the petal length and the width. Okay? And the y sub I are the target labels. So it's like we are going to predict if, for example, this is the petal length or the sepal length or width, then what would its species be like? Something like that. And so we do the train test split here as well. Actually, same with the breast cancer. Okay, first is the iris data set, next is the breast cancer. And then in the dataset preparation, we do the train test split, and the test size is about 20%, and 80% of course will go in the training portion. So for example, we have 120 samples, 150 samples, then 120 for that. That's 80%. That is a training. We train 80% of the 150, and then we test the remaining number of that sample. So out of 150, 120 it is, we train it, and testing is 30. So next is the loading the breast cancer dataset. So we load iris. Of course, we load also the breast cancer, right? Same process. So we load the breast cancer. Okay, in this breast cancer that we have, the data set that we have rather in preparation is that it's a binary classification problem. So we use logistic regression for this one, right? So we talked about the malignant versus the benign. And what else? The train test split as well. That's also 20% is the test size, and 80% goes to the training side. So in this data set, for example, there are like 569 samples. 455 will be for training, and the rest will be for testing. That's 114, right? So we can create a confusion matrix out of that. And then we do the feature scaling. Of course, we scale features as mentioned earlier. Scaling is important because some other algorithms, such as logistic regression rather, they are sensitive to feature magnitude. So we scale them. So if we standardize, there's a faster convergence, there's a fair contribution to all the features, and of course, better stability for numerical values, right? So Afterwards, we print, we interpret the output, right? The iris train shape, that's 120 and 4. And the breast cancer train shape, that's 455. 455 is a training, and test is 114. Yes, for the breast cancer. This one and this one. All right. For the next task, which is the naive-based classifier. So in the naive-based classifier, we the purpose of this task actually is to demonstrate how the Gaussian naive Bayes is also used for binary classification, such as the breast cancer dataset, and how will we evaluate its performance using the standard classification metrics. So for the model used, this is naive Bayes, right? The Gaussian naive Bayes. And then we import it, of course. So this assumes that features are continuous and each feature allows a Gaussian distribution. So the features are conditionally independent given the class label as well. So in the model training for naive Bayes, so this one, NB equals Gaussian NB, and we have the NB that fit, then we have its features, X sub B, and etc. The model learns such as the class prior probabilities, the mean and variance of each feature per class. So we have that the training is computationally efficient and of course fast. And in the prediction, we have Y sub B underscore predict underscore NB, that's the base. We use nb.predict, the predict function. Okay, so this line here predicts whether a tumor is malignant or benign based on probability estimates. And then we have the accuracy results. The accuracy is about 93.86%, and it is almost it's almost 94%. And so again, since the model correctly classifies 94%, almost approximately 94%, so it indicates a very strong performance actually for a simple probabilistic model. So if you can see here in our confusion matrix, we have 34 true positives. Okay, 4 is the false negatives. So it means that malignant cases are predicted as benign. So meaning to say that yung dangerous cases were predicted as not dangerous. So it's very critical in medical diagnosis. We have three false positives. So it's benign, predicted as malignant. And in healthcare, so take note that I may mention also in our lecture in AI that we have to minimize false negatives. Okay, again, especially in healthcare. So 69 were correctly predicted for the false positives. Okay, so take note also of the precision of malignant, recall, and F1 score, and as well as the benign. So these are really, really high. So if we use the logistic regression classifier, we have here, of course, the import, and we have to say we have to import as well pandas and name it as PD, so that on the next lines we use the word PD instead of pandas, no, which is quite long. So what is logistic regression again is that it's a linear classification model that yung sinabi ko estimates the probability of a class, and that uses the sigmoid or the logistic function, and it's very suitable for binary classification. So outputs are within the threshold, so default is 0.5. for class prediction. So for the model training, we have here the logistic regression, which is LR, calling the function logistic regression, and the max iteration of 1000. So here, training is performed on standardized features. We have xb underscore tr underscore x because, again, in LR or logistic regression, it's very scale sensitive. And the model learns both coefficient for each feature and also an intercept. For the prediction, we have this line here predicts whether a tumor is malignant or benign, and it's based on learned decision. And we see that accuracy result is actually higher, right? Which is 98%, 0.25%, and very, it's actually notable, and a more notable improvement than the naive Bayes. So, if we try to compare the confusion matrix, it has only both one of false positive and true negative, right? True positive rather, and false negative. So, no, the false only one false negative and false positive. So, isa lang yung namali sa benign and sa malignant. So, it has higher, no? One false negative, it's malignant predicted as benign. One false positive, benign predicted as malignant. So, this algorithm significantly reduces critical errors, right, compared to the naive Bayes. That is why logistic regression is very, it's better if we use logistic regression if we predict only two classes. So as if you can see, again, the overall accuracy is 98%. Malignant precision, both malignant and precision and recall for malignant, that's 98%. As well as actually the F1 score, and also the benign, that's all three are 99%. So almost all malignant cases were correctly identified, as well as for the benign class. So actually, we also have the feature coefficient analysis. This just means that the top features by coefficient influence features with larger absolute coefficients and have greater influence predictions. We have positive coefficients increase the likelihood of predicting malignant, and etc. And this actually is now another task in your lab exercise 6 is the text classification using both algorithms, naive Bayes and logistic regression, and we want to compare which of these algorithms perform better than the other one, right? So the first one is to import or fetch the news groups here. Actually, unsa ni siya? It's a well-known text dataset for document classification. So there are only two categories used here, and it using these two classes simplifies a task into binary text classification. So if you have heard of the term text vectorization, so that is the TF-IDF, no? This one. So we import that one. So this line converts raw text into numerical feature vectors. So the TF-IDF increases weight of important words and reduces impact of common words. So the word the stop underscore words in English removes common. So English stop words examples are kanang the, is, ug and. And this is very crucial because the machine learning models require numerical input, hindi yung raw text. So instead of having words, we convert it into numerical inputs, something like that. And then we have the train test split as well. Still 80% training and 20% is for testing. Okay? So you just have to follow everything in this lab exercise, no? So that we can get the same output for both naive Bayes and logistic regression. Actually, both have 99% accuracy. One is 99.16 and the other is 99.58. Yes. So in the comparison of models class, both achieve very high accuracy. So logistic regression shows a very small but has a consistent improvement, whereas naive Bayes it remains faster and also very simple to train as well. And at the end, I would want you to compare and reflect. And these are some of the discussion prompts that you can use in reflecting and comparing both. So I hope you have had a fun time learning and of course doing this lab exercise as well. And hopefully you can utilize using AI in your future projects. Thank you so much for listening and goodbye.